So let's take this a step further with forces on charged particles. Since they cause the thing to go in a circle, one of the things we do is we say, okay, the magnetic force is, if we're at right angles to the magnetic field, the magnetic force is QVB. And then we say, we also know that to make it go in a circle, the centripetal force needed is mv squared over r, like this. So we can actually do problems where we set the QVB equal to the mv squared over r. Okay, so let's do an example of that. Okay, so we got a proton going some strangely specific velocity, right? And so let's figure out actually the radius of the path it travels in, right? So I'm going to go QVB equals mv squared over r, right? And I want to solve that for r, so I'm going to just cross multiply. So r is mv squared over qvb, and then I can cross out of v, and I end up with mv divided by qb. Okay. Now this isn't a formula in the data packet. You always have this. Actually, you don't have that in the data packet, but you have f is qvb, and you have f equals mv squared over r. You have to figure out that this equals this, right? That's not too hard. Okay, and then what I suggest you do is solve for the thing that you want to find, right? So I'm going to actually find the radius of its path, right? Okay, notice that this radius makes sense. The bigger the mass, the bigger the circle it goes in, right? It's hard to make a heavy thing go in a circle, right? The faster it's going, the bigger the circle. The bigger the charge, of course, the better grip the magnetic field has on it. So the tighter the circle, the bigger the magnetic field, the tighter the circle. Okay, so now we can just plug the numbers in, right? You have to look up in the data packet the mass of a proton is 1.673 times 10 to the minus 27th kilograms. And then there's a strangely specific velocity, 4787.81 meters per second. And then we're going to divide by the charge, 1.602 times 10 minus 19th coulombs. And then our magnetic field is 5.0 times 10 to the minus 5th Teslas. And somehow a meter is a kilogram meter per second per coulomb per Tesla. You could figure that one out. I leave that for the talented and gifted among you. Okay, so let's see. 1.673 e minus 27 times 4787.81 divided by 1.602 e minus 19 divided by 5 e minus 5. And when I do this, amazingly, the radius ends up being 1 meter. 1.00, it's 1.000000765 meters, okay? Isn't that cool? That's cool. Right? It's like, whoa, holy coincidence, right? Okay, so this thing, let's figure this out. This is our velocity, so put your index finger that way. Put your middle finger out of the page. Out of this page, right? And of course, if you do that, your thumb is now pointing down the page, which makes this thing, it's actually going to go in a circle like this, okay? Here the force will be up, here the force will be in. You can figure all this out, right? And this circle will have a radius of 1 meter. Okay. Let's do some examples. You can solve some of these.